Hello and welcome. Today, we are stepping into the kitchen of machine learning. Seriously, we're going to explore how data scientists take all these raw, messy ingredients, which is, our data, and turn them into a gourmet meal that's ready for even the most advanced AI models. So let's go ahead and put on our aprons and get prepping.
It's a fair question, right? I mean, we've got these incredibly powerful algorithms, these massive models, so why can't they just figure it all out on their own? Why do they need us to be the prep chef? Well, the answer is actually pretty simple, and it all comes down to quality.
And right there, that's the main idea for our entire explainer today. If you feed a model messy data, you're going to get a messy, probably unusable result. To create a masterpiece, you have to wash, chop, and prepare all your ingredients with a lot of care. So our journey starts right here. We're going to transform that chaotic pile of groceries into a structured, reliable recipe that our model can actually follow. You got to remember, this is the absolute foundation of any successful machine learning project. Okay, first up, we need to clear the air on two terms that get thrown around and used interchangeably all the time, but they actually mean very different things: data cleaning and data preprocessing. Just think of them as the first two critical stages of our meal prep. So, data cleaning. It's exactly like washing your vegetables and cutting off any bruised or bad parts. It's all about fixing the data. You're getting rid of the dirt, the imperfections, just to make sure that what you're left with is accurate, consistent, and totally reliable. So, what does that actually look like in practice? Well, it means you're filling in the blank spots where data is missing. You're getting rid of identical entries. You're removing those really bizarre values that just don't make any sense. Those are your outliers. And you're fixing simple typos or formatting mistakes. It's that essential first quality check. Okay, now let's talk about pre-processing. If cleaning was just washing the veggies, well, pre-processing is pretty much everything that comes next. We're talking about the chopping, the peeling, the dicing, maybe even marinating. It's a much broader category that takes our now clean data and gets it into the perfect shape and format for our specific recipe, or in this case, our algorithm.
And this table right here, this really just nails the difference. The goal of cleaning is simply correctness, making sure the data is trustworthy. But the goal of pre-processing? That's all about optimization, making sure the data is perfectly tailored to help our model perform at its absolute best. Two different goals, two different impacts.
So our ingredients are clean, they're ready to go. Now comes the part where the real skill and creativity come into play. This is section 3, the art of features. This is where a data scientist really earns their stripes as a master chef. So what exactly are features? Well, to put it simply, they're just the individual pieces of information our model is going to use to make a prediction. In our kitchen analogy, these are the fundamental ingredients, the carrots, the onions, the spices, that are going to define the final flavor of our dish. This whole process is called feature extraction. It's kind of like using a food processor, right? We're not just changing the shape of the ingredients, we're fundamentally altering them to make them more potent and way easier for our model to, digest and learn from. And this breaks it down so well. Feature selection is like deciding, you know what, I only need the carrots and onions, not the celery. Transformation is like grating the carrot instead of just dicing it. Dimensionality reduction, that's like making a super concentrated stock. Less volume, but all the flavor is still there. And feature construction, that's the real magic. That's combining ingredients to create a totally brand new sauce that just elevates the entire dish. Let's zoom in a little on that idea of concentrating the flavor. Two really popular ways to do this are PCA and LDA. Think of PCA as finding the core essence of a dish. It might figure out that the combination of saltiness and richness explains most of the flavor profile. LDA, on the other hand, is way more specific. It's designed to find what best separates two different dishes. For instance, it would focus on the features like creaminess versus brothiness that most clearly distinguish a soup from, say, a stew. Now, this is a super crucial point, really understanding the nuance here. Feature transformation, things like scaling numbers or encoding categories, that's a technical step. It's a part of the larger process. But feature engineering is the whole creative shebang. It includes transformation, sure, but also the selection and, most importantly, the creation of brand new features, all designed to boost your model's performance. Before any chef sends a dish out of the kitchen, there's one last, absolutely vital step. They taste it. And in data science, we do the exact same thing. We have to validate our data's accuracy. And this slide gives us a really practical 6-step checklist for that final taste test. You start by checking your source. Are you getting your ingredients from a reputable supplier? Then you compare with other sources and check for updates, just to make sure your recipe isn't out of date. You also have to spot errors. Does anything just look or taste off? And if you're ever in doubt, you can ask a domain expert or use specific tools. Following these steps ensures you're serving up something truly trustworthy. This quote really just captures the essence of everything we've been talking about. It's not just about being clean. It's about being perfectly structured and transformed to give your algorithm exactly what it needs to succeed. And there you have it. We've actually done it. We've taken that raw, chaotic pile of data, and through cleaning and pre-processing and some artful feature engineering, we've prepared a sophisticated, nutrient-dense meal that's going to power our machine learning model to achieve some amazing results. So, I'll leave you with this question to think about. Is this whole process meticulous science, where you have to follow a strict recipe? Or is it more of a creative art, relying on the intuition and domain knowledge of a master chef? The truth, as you can probably guess, is that it's a delicious combination of both. Thanks so much for watching.